Okay, so we're going to end week 2 with a really short video. There are 4 slides. This is 1. This is 2. Okay, so we're going to talk about oxidative capacity of a muscle. So to start off, well, what does oxidative capacity mean? And really, it's just how well are we able or something able to use oxygen. So if you have high oxidative capacity, it's able to use a lot of oxygen. Okay, so we've talked about, or you should have learned in your human physiology class, that there are 2 primary types of muscle fibers, okay? And we'll get into more detail later on in the semester, okay? But to keep it simple, we're just going to say there's fast and there's slow. So type 1 are slow, and they're very oxidative. You use these for long duration, low intensity activities. So as you sit here trying to stay awake while watching this video, you're using type 1 fibers, unless for some reason you happen to be watching this while you're on the treadmill at the rec. Okay, then you're probably not using just type 1 fibers. You're definitely using some type 2. Type 2 fibers are not oxidative. We call them glycolytic. Okay, they don't have the ability to use oxygen, therefore they don't require a lot of oxygen. But they can do a lot of other things, or they can do different things compared to these oxidative or these slow twitch fibers. Okay, they can produce a lot of power. They're very quick, but they also tire out very easily. And so there's more to come on that later. And we're just going to focus for this next slide on type 1 fibers. Okay, there's several properties of type 1 fibers that I liken unto a factory. Okay, and so here's a picture of, I believe, the Boeing plant in Everett, Washington. Okay, this is a massive building. All right, I've actually been in this building. It's crazy, especially when you see like 15 747s parked inside of this building. It gives you an idea of how big it is. Okay, so if we increase the number of capillaries, or of type 1 fibers, not even increase it, they just have a high number of capillaries. Okay, so they're able to get lots of oxygen in the muscle cell. That's great, but that's not the only thing. I don't need to get oxygen into the muscle cell. I need it to get it to the right place. Well, that's where myoglobin comes in. Myoglobin is a transporter, and it helps get oxygen from the cell where it's floating around into the mitochondria. Okay, and then we've got mitochondria. Mitochondria are just factories. Okay, they're energy factories. They're energy producing factories. So if I have more mitochondria, I have more factories. If I have more factories, I can produce more ATP. Another thing that happens is that I've got bigger or larger mitochondria. A bigger factory can produce more of something, right? So if I've got a factory that can produce or can hold 1 747 as opposed to a factory that can hold 15 747s, I'm going to be able to produce more in the one that's bigger. Okay? And then the other thing, as we've talked about as we've gone through these energy systems, is that enzymes are required. Okay? And so type 1 fibers have higher levels of mitochondrial enzymes, and really they have higher levels of mitochondrial enzymes that are designed to help promote aerobic processes. Okay, and so as a result, if I've got more enzymes, my factories, my mitochondria become more efficient. I can produce more ATP. Okay, this is what's going on in type 1 fibers. Type 2, it's kind of the opposite. And it's not that they have less mitochondrial enzymes, they just have less of the ones that need oxygen or that help with oxygen production of ATP. And so that's how we're going to end week 2.